Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day everyone. Alright, so today for our asynchronous class, we are going to start with a new chapter, chapter 3, which is Laplace transform. Alright, so what is Laplace transform? Maybe to some of you, this is the first time you have ever heard about this Laplace transform. But maybe, and I'm not sure, for those who are diploma leavers, maybe this is not the first time for you to dengar about this Laplace transform. So, the learning outcome for today, okay, upon you completing viewing my video, you are able to understand what is actually Laplace transform and why do we have to learn about this Laplace transform. Alright, so that is the aim for today. Okay, basically this chapter 3 consists of the following subtopics. We have introduction, where I think today we, of course, we will go for it shortly. Definition and basic properties, Laplace transform, it has the general formulas, and here we have the table of Laplace transform. Then we have shift from the Laplace transform to kita ada dia punya theorem and properties. Okay, the Heaviside function, shifting theorems. And after that, we will have inverse of Laplace transform. This is another important as well. Okay, one important thing, inverse of Laplace transform. And then we have differentiation and integration of the transforms. And finally, okay, this subtopic is actually summarized on what have you learned previously. Solution of initial value problems. Okay, what does this mean? Okay, later on we will relate it with the introduction very shortly. Okay, makna kata kalau you boleh faham the last subtopic, maknanya you khatam, understand very well the rest of the content for this chapter 3. Alright, so let's begin with the introduction. Okay, if you have a look over here, okay, it is stated that the purpose of the Laplace transform is to transform ordinary differential equation to algebraic equation, which makes it easier to solve ODEs. Okay, so that's why lah chapter 3 ni Laplace transform right before right after we have completed chapter 2, okay, ordinary differential equations. Okay, makna katanya kenapa you have to learn Laplace transform? Because Laplace transform will offer you an alternative solution, ataupun there's another type of solution untuk solve ordinary differential equation. Ingat dalam chapter 2 kan kita dah belajar berapa method dah to solve the ordinary differential equation. For first order differential equation, we have 3 methods, right? We have separable equation method, we have integrating factor method, and we have exact equation technique, right? For first order. For the second order differential equation, we have dia punya step where y is equals to yc plus and dia depends dulu kan. Whether it's homogeneous. Kalau homogeneous, kita depends, kita ada 3 possible cases tu, depends for b square minus 4ac. Kalau dia non-homogeneous, then you need to consider yc plus with yp, that you have to make a guess and so on and so forth, right? So those are the techniques. In this chapter 3, actually, why you need to learn about Laplace transform? Because Laplace transform will offer you another possible technique to solve the ordinary differential equation. Okay, faham setakat ni kenapa you perlu belajar Laplace transform? Okay, there is an advantage compared to the techniques that we have learned in chapter 2 to solve ODEs. Okay, using Laplace transform, okay, problem are solved more directly, okay, because it's been transformed to algebraic equation, okay, without determine a general solution. Okay, ingat tak yang kita buat YC plus YP tu kan, kita decide dulu you have need to find the constant and so on, right? Okay, you need to compare left hand side and right hand side. This is correspond to the second order ODE. And then here stated as well, non-homogeneous ODEs are solved without solving the corresponding homogeneous ODE. Okay, maknanya dia tak perlu mula-mula let YC, cari YC dulu, lepas tu tambah YP. It can just be done directly, one off, then you get the final solution. Okay, basically there are 3 steps. Okay, the given ODE is transformed into algebraic equation, which is called as the subsidiary equation. Okay, maknanya ni dia akan berada dalam bentuk Laplace transform. Okay, and then subsidiary equation is solved by purely algebraic manipulations, and the step 3 solution in step 2 is transferred back, okay, into the solution, okay, of the given problem. Okay, so basically to solve this, okay, step 1 ni transform. You need to transform first your given ODE into the Laplace transform. Jadinya, the first thing that you need, tadi lepas tahu kenapa you kena belajar Laplace transform, the next thing is you need to know what does it mean by Laplace transform. Kenapa? Sebab lepas ni you nak transform your ODE into its Laplace transform. Okay, so here we are, definition and basic properties of Laplace transform. Okay, so basically Laplace transform ni adalah kita ubah, okay, equation tu from kalau sebelum ni kita ada apa? Equation kita y equals to fx ataupun y equals to ft. Am I right? Okay. So in this case maksudnya kita punya ni into space domain. Okay. Dia punya position. X ni kan position kan, into space domain. Ataupun dalam t ni maknanya dalam time domain. Alright, so Laplace transform is nothing but it's just another type of domain, okay, where we call it in Laplace domain. Okay, so Laplace domain here we represent by letter S. Okay, so basically maknanya daripada fx ke ft ke, depends lah, dia punya input signal dia masuk dalam ni, okay. Okay, saya guna macam ni, maknanya ni dah adalah proses untuk kita transformkan dia. Nanti dia akan keluar dalam, okay, hasil kita adalah dalam bentuk transform. Okay, Laplace transform. Okay, so Fs ni, capital Fs ni indicates that your function has been transformed into Laplace. Okay. Alright, so alright, so the next persoalan adalah macam mana kita nak buat transform tu. Okay, tadi kan kita kata the signal ft ke fx ke masuk dalam transformer ni dan dia akan keluar dalam bentuk Laplace domain. Okay, how does the process take place? Okay, how does the process take place? Ni lah dia punya transformer tu. Okay, how to transform from time or from the space domain into the Laplace is by using this formula. Integration of 0 to infinity e to power of minus st darab dengan our function yang kita nak transform tu ft respect to dt. Alright, kalau fx x, kalau x lah, kalau maknanya kalau yang ni dia akan jadi fx dx e to power of minus sx. Okay, furthermore the given function ft in 1 is called is called inverse transform of fs, okay, denoted by L inverse. Okay, kalau kita dah transform dah dapat fs ni, boleh possible tak kita nak kembali ke dalam bentuk time or space domain fx ni? Jawapan dia yes, possible. How to get back? You need to use the inverse of Laplace transform. That's why tadi saya tengok, saya senaraikan dalam kita punya outline, we have one subtopic particularly to discuss about the inverse of Laplace transform. Okay. Alright, so we shall write this. Okay, dalam bentuk macam ni, ada inverse ni to indicate that we are able to get back. Okay, macam mana formula ni? Kita boleh kata benda ni adalah Laplace transform. You tanyalah pakcik ni. Okay, Pierre Simon Marcus de Laplace. Dia lah yang kira cipta lah. Okay, this Laplace transform. In fact, this Laplace transform ni pun dia punya nama is taken over his name. Okay, a great French mathematician, was a professor, blah blah blah. Okay, minat nak tahu pasal dia. Okay, Napoleon Bonaparte. You all tahu tak siapa ni? Napoleon Bonaparte ni was also his student for a year. Okay, boleh google lah pakcik ni nak tahu detail about him. Alright. Okay, so let's begin. Cuba tengok example ni. Okay. Saya dah bagi soalan ke? This example ni saya tak denote sebagai any example number lagi. Okay, let ft sama dengan 1. Okay, maknanya kita ada a function ft, okay, is equals to 1. Macam ni je lah, ft equals to 1. Find its Laplace transform fs. Okay, find its Laplace transform fs. So, kalau nak kira, guna dia punya formula tadi kan. Okay, formula Laplace transform tadi apa dia? Okay, integration from 0 to infinity e to the power of minus st ft dt, right? So for this question, ft is equals to 1. So ganti je lah dengan 1. So that's why your integration jadi e to the power of negative st dt, integration from 0 to infinity. So to integrate e to the power of negative st respect to dt, ni macam biasa je lah, you integrate exponential function macam mana. Okay, we copy back the question and we divide with the derivative of the power kan. So we have negative 1 over s e to the power of negative st. So the upper limit is infinity, the lower limit is 0. So basically yang ni maknanya kita gantikan dengan negative 1 over s ni, tak ada apa dah. Okay, you just need to put in, replace t with negative e to the power of negative s darab dengan infinity. Okay, minus with e to the power of negative s darab dengan 0. Right. So, e to the power of negative s infinity ni, okay, kalau you tengok, maknanya benda ni adalah 1 over e to the power of s darab infinity. Yang ni pula e to the power of kosong, so dia akan jadi 1. Am I right? Okay. Okay, so 1 s darab infinity, apa benda value s ni pun, once it darab dengan infinity, it will be a very big number, right? So 1 over a very big number, dia akan jadi very close to apa? Very close to 0. Betul? 1 bahagi sesuatu yang besar, you will get 0.000 something. So here, you will get negative 1 over s, kosong tolak 1. So the final answer will be positive 1 over s. Clear everyone? So maknanya the Laplace transform for the function ft equals to 1 is 1 over s. Okay. Alright. So ni tak ada apalah. Ni dia explain further pasal macam mana kita dapat 1 over s ni. Alright.